Hey guys, we want to calculate the limits using the law of limits. Okay, and this is not very difficult today. We will get to some table examples, some algebra examples, and then some more conceptual ideas. But the idea is this: the limit as x goes to a of f of x plus g of x is going to be the same as the limit as x goes to a of f of x plus the limit as x goes to a of g of x. So we're able to separate it into those two pieces. Instead of writing it for all of these, can you agree that for subtraction, we'll separate to subtraction? On a constant, we'll have a constant. Multiply, we'll multiply, and divide, we'll divide. Okay, so let's look at one that you might struggle with. Suppose my function was a constant. Say y is equal to 4. And as you consider that graph, what kind of graph is that? Horizontal line that passes through 4. So let's say I'm approaching some value a. What is the output always approaching for that function? It's always approaching 4. It's always approaching the constant, right? So the limit as x goes to anything of a constant is the constant. Fair enough? How about if we have the function x? Horizontal line. If I plug in a, what do you get? You get a. So whenever you're approaching a, the function will approach that value. And it works out very well that we can just simply plug in a to most of these situations. So if you have a polynomial, you can plug in a. If you have a radical function, you have the nth root of a in the scenario. If you have the nth root of a function, you can take that function of a to the 1 over n power. Those are all things that you already know how to do. The short of it is this. If you have a polynomial or a rational function, a polynomial would be like f of x is equal to x to the 4th minus 5x squared plus 1. Okay, a rational function would be something like f of x is equal to 2 over 3 minus x. Or a radical function involves a root. You can always just simply substitute a in. So if you want to know the limit, just simply substitute a in for x, and it will tell you the limit. So we know that because they're very nice behaving functions. They don't have quirky things going on with them, really. It's going to be okay. So let's try a little bit conceptual idea here. We don't actually have a function rule, but it does tell us that the limit as x goes to a of f of x is 6, of g of x is negative 2, and of h of x is 0. Okay? So I want to know the limit as x goes to a of f of x plus g of x. Well, I'm going to use our first limit idea. I will separate this, and I'll only do this the first time, into the limit as x goes to a of f of x plus the limit as x goes to a of g of x. Do I have those exact same two pieces written down above here? What can I substitute for limit as x goes to a of f of x? 6. How about the next part? So this gives you 4. Easy enough? Yes, Claire. Because I'm an idiot. Thank you. Up for the 11? Oh, I just forget to write it all the time? Oh, I'm an idiot. All right, sorry. Okay, we move on to the next one. Limit as x goes to a of f of x divided by h of x. What is f of x going to be? 6 h of x. Now, you might be tempted to say that then the limit does not exist. That's not for sure true, okay? It might be infinity. It might be negative infinity. We don't know. And so a better response in this situation will be undefined, okay? IDK, WDK. We try C, negative 3 times g of x plus 5. You'll simply just evaluate the limit as x goes a of g of x, multiply it by 3, and then add 5. So what is, that's negative 2. So you get 6 plus 5 is 11. Do D on your own. Okay, go get some brain food. Come on back. We'll get to it later. We'll get to it later. We'll get to it later. So. I want to hear. I know that one, but I want to know the other one. Okay. All right. We will show the star quality of restraint. You're not up there. Okay, here we go. Okay, let's do it. The graphs of f and g are given. Use them to evaluate the limit if it exists. If it does not exist, explain why. Here we go. Instead of being given the limit, we have to find the limit. What is the limit as x approaches 1 of f of x? You tell me. I approach 1, and I get 3. Divided by, now I'm going to approach 1 for g, and I get negative 1. It's not the function value, it's the limit. F of 1 is 4, but the limit as x approaches 1 is 3. Okay, look at B. 2 times f of x. 2 times, what is the limit as x approaches 0 of f of x? Sure. Well, I would say that that's a good estimation. Better? Okay. All right, now 3 times as x approaches 0 of g of x. So we've got 5 plus 6 is 11. Oh, come on in. It's our guest. Okay, we move on. Limit as x goes to 2 of g of x. What's the limit as x goes to 2 of g of x? Does not exist, folks. Because you got to approach it from the left, and you have to approach it from the right. And you see that it's not the same from the left or the right and the right. So therefore, it does not exist. Divided by the limit as x goes to 2 of the function, f of x is about 2.5. If one part of it does not exist, then the entire thing does not exist. Look at D. Limit is x goes to 5 of 2x squared times f of x. So I'll figure out what the limit is x goes to 5 of f of x is. 4. So you end up with the limit as x goes to 5 of 2 times 5 squared times 4. So I'll plug the 5 in for the x, and I get, because the limit as x goes to 5 of the function is 4. Okay, we'll try one more time. If I substitute 5 in for x, I get the limit as x goes to 5 of 2 times 5 squared times f of 5. So I need to find the limit of the function as x approaches 5. And as you look at that right here, as x approaches 5, the limit approaches 4. So therefore, this part right here is 4, and we get 200. Okay. So let's get to some algebraic examples. You guys usually tend to like this better. Okay. If you can substitute it in, then you substitute it in. The limit as x goes to 1 of x to the fourth minus 3x squared plus 1. Can you plug in 1? Yeah, you get 1 minus 3 plus 1 is negative 1. Done. Can you plug in 0 for the next one? What's the cube root of negative 27? Negative 3. Done. Can you plug in 3 here? If you plug in 3, what would you get? Now, 0 over 0, you don't know. Do not do this. This is an indeterminate value. We don't know what 0 over 0 is. We can't write 1, you can't write 5, you can't write 20, but maybe you can do something to figure out what it is algebraically. What can I do? Yeah, factor the top. We'll get more to indeterminate values later on in the course of the year. In this way, we could just handle it by doing some fancy algebra. Cancel out our x minus 3's, and you get 6, 1 less than 7. All right, how about D? Can you plug in 0? If you did plug in 0, what would you get? 0 over 0, which we don't know what 0 over 0 is. Yeah, I'm going to rant for just 10 seconds here. All right, we're on the same page. So I get 0 over 0, so I got to factor out x. What happens? X's go away. Can you plug in 0 now? You get negative 5 over. Awesome. Flip it. What happens if you plug in 0 here? You get 0 on the bottom and 0 on the top. Let's try some fancy algebra. Limit as h goes to 0 of h squared minus 4h plus 4 minus 4. How did I get that? I multiplied it out. What happens? 4's cancel. What else happens? Factor out the h. So I get a limit as h goes to 0 of h minus 4, which is negative 4. Thank you, Dulitzer. Well, the next one. Can you plug in 0? No, you get 0 over 0. What do you want to do? Cube it out. Sounds like a lot of work. Remember Pascal's triangle? Remember it now? So if you cube h to the third, you get h to the third. You're going to get h squared times 1. You're going to get h times 1 squared. And you're going to get 1 to the third, which is 1. Now all I need is my coefficients. My coefficients would be 1, 3, 3, and 1. What happens? And 1's canceled, take out an h, you have the limit as h goes to 0 of h squared plus 3h plus 3, which is 3. Say it loud and proud, folks. How about G? Because right now you're feeling pretty smart. How are you going to get rid of the square root, buddy? Oh, okay. All right, you guys. Multiplying by a conjugate is an option. That is an option. Squaring it is not an option. Can I show you another thing to do? This is tricky. I'm going to factor it. Watch. Everybody agreed? You okay with that? So watch this. You agree that 9 minus x squared factors to that? 9 minus x factors to 3 minus the root of x times 3 plus the root of x. Right? So I'm going to, what? Yeah, you don't always remember everything. Limit as x goes to 1 of 1 minus the root of x times 1 plus the root of x all over 1 minus the root of x. Yeah? Now what? The 1 minus x factors to that. Dose. Good. Never mind is an album by Nirvana. All right. How about H? Can't plug in 0. I'm going to use the conjugate idea now because we needed to get rid of that H in the denominator, right? And it would be nice if we could free up an H in the numerator that would cancel it. So I really centers around trying to get rid of that square root. Well, one way to get rid of the square root is to multiply top and bottom by H plus 9 plus 3. Right? So square root of H plus 9 times square root of H plus 9. H plus 9. What happens to the middles? That's the whole idea of multiplying by a conjugate. The middles will cancel. Negative 3 times 3. And then in the denominator, watch, I'm going to write this as H times the quantity, square root of H plus 9 plus 3. All right, what happens in the numerator? 9s are gone. And H divides off. So that means I got the limit as H goes to 0 of 1 over the square root of H plus 9 plus 3. Can I now plug in 0? What do you get? Sweet. Anybody know what time we're done here? 17. Okay, we're running out a little bit of time here. So, oh, it's 17? Okay, we've got this in. Okay, can I plug in 0 here? I can't, because I get 1 over 0. I get negative 4 in the denominator, but I get 0 here. Maybe something will cancel if I reduce this complex fraction. So we'll have the limit as x goes to 0. I should multiply the top and bottom of this by 16. Top and bottom of this by x over 16x over x minus 4 over 1. Complex fraction. How do I simplify a complex fraction? Multiply by reciprocal. I will also factor the top there, 4 minus x times 4 plus x over 16x. And when I multiply by reciprocal, I get 1 over x minus 4. Can I cancel out the x minus 4 and the 4 minus x? Are they the same? They're different by a factor of negative 1. So I'll cancel them out, but I have to attach a factor of negative 1. Can you plug in 0 now? No, we still get 0 in the denominator, don't we? This is a problem where you cannot use algebra to solve it. We have to look at a table or at a graph to Take out your calculator. I'm going to take 4 plus x and divide it by negative 16x. And I'm going to zoom standard. Kind of tough to see what happens there, huh? So what's the x value approaching? So let's approach 0 by using our table. If we want to approach 0, we will go negative 1, negative 0.1, negative 0.01, negative 0.001. So as you approach, what's happening to the values as you approach 0 from the left? It's getting, yeah, so you think it's headed towards, it's getting ridiculously large. Yeah, it's going towards infinity. I mean, it's multiplying by a factor of 10 every time. I mean, it's getting really, really, really large. So then let's go to 0 from the positive side. And we get 1, 0.1, 0.01, 0.001, 0.00001. Negative infinity. So is it same from the left as it is from the right? So if it's different from the left and the right, then does not exist. Similar to the next one. Again, we cannot get rid of that or deal with it really algebraically, so we'll look at it from a graphical standpoint. Y equals, and you know how to find absolute value on your calculator. You got two options. You either go to math or you go to second catalog. Absolute value pops up right there. X plus 5 divided by parentheses x plus 5. Zoom standard. And you have to understand what's going on with this type of problem, but it's undefined at negative 5. So let's think about this. As x approaches negative 5 from the left, what's the limit? Negative 1. As you approach negative 5 from the positive, what's the limit? Are those the same? Folks, have a nice guy. And because I am, I'm going to give you a work day tomorrow. There's your assignment. I will also have a study guide ready to go for you tomorrow. You have an assignment on Tuesday, a work day on Wednesday to prepare for your test on Thursday. Fair enough?